Welcome to Physics Week 1, where we will be discussing Newton's first, second, and third law. Newton's first law of motion concerns inertia. What is inertia? Inertia is an object's resistance to changing its motion. In other words, an object at rest will stay at rest unless a force acts upon the object. In this example on the screen we are looking at, a hoop is placed over a bottle. On top of the hoop sits a whiteboard marker. The whiteboard marker is at rest. The question is, what would happen to the whiteboard marker if the hoop has been displaced using an external force? As we can see, when the hoop is pushed away, the whiteboard marker will fall due to gravity and enter into the bottle. Let's look at a video of inertia in motion. This experiment will demonstrate the concept of inertia where an object at rest stays at rest. There we see the hoop being removed and the pen or the marker falling into the bottle. Newton's second law of motion deals with acceleration and velocity. Velocity is defined as distance over a period of time. In other words, velocity is a rate. However, velocity alone is half the story, as we must also define the direction that the velocity is aimed towards. In Newton's second law of motion, acceleration is the result of an unbalanced force acting on it and is also dependent on the mass of the object. In other words, acceleration is equal to force over mass. We might have seen this in a different format before, where force equals mass times acceleration. Looking at the equation in front of us, if we multiply the left and the right side times m, that would give us our original force equals mass times acceleration. What does this tell us about Newton's second law? If there's no force applied, there will be no acceleration. The converse is true as well. If there's no acceleration, we can also assume that there was no force acting on the object. Newton's third law of motion is that for every action, there is an equal and opposite reaction. This is also called the conservation of momentum law. When one object pushes a second object at some point of contact using an applied force, there must be an equal and opposite force from the second object that cancels the applied force. In this instance and this example, we're looking at blocks pushing weight towards the ground. However, the opposite force is the ground pushing back on the block. In summary, the three laws of Newton combine to make the following formula that we have seen in the second law. Force equals mass times acceleration, one of the basic principles of physics, and the equation we will be studying in depth for week 1.